Hello, I'm Dr. Harper. This lecture is on operations management, and this is a lecture video on aggregate planning. So let's bring up the notes. In aggregate planning, we have the input-output process. The input of the resources, they're all different kinds of resources. The two resources we'll be looking at primarily in aggregate planning would be inventory and labor. The output is a production plan. And so the whole point and objective of an aggregate plan is creating a production plan. But that production plan goes through an aggregate planning process. And in this process, the concept is connecting your resources with your production plan to create strategies, to create objectives, to have different applications and characteristics. And we'll be talking about some of those in this lecture. Now, the whole concept of aggregate planning is four things: the demand, production, the resources, and labor. And so if you have an inventory, if your inventory, if your demand is constant and your capacity is constant and level, and you produce a level and your demand is level, what happens in inventory? It stays pretty much the same. But if your capacity stays level and your production stays level, but your demand goes down, then the inventory goes up. Likewise, if the demand goes up, inventory goes down if your production stays level. So that relationship between inventory, capacity, demand, and productivity, that relationship between those four variables, that's what aggregate planning captures and creates some very powerful strategies. On the other hand, if the demand goes up, your capacity goes up, production goes up. If the demand goes down, your capacity goes down, production goes down. And if you can chase that, then what happens in inventory? Inventory stays pretty much level and constant. It doesn't change. So those four things is what we will be looking at in this lecture. And as it turns out, when you begin combining those, the demand, productivity, capacity, and inventory, then what happens is you have some very powerful strategies. So the aggregate planning has different names. We're looking at aggregate planning because that's kind of a catch-all term for top-down analysis. Now, production planning is focusing on the output. The whole point is creating a production plan. But sales and operations planning focuses on connecting the production, the demand, the sales with operations. But all of these are under as far as I'm concerned, the way I'm teaching this, it will be under the umbrella of aggregate planning. So let's first start with strategies. There's two primary strategies: level capacity and chase demand. And down here we have some simple examples to illustrate those two strategies. And so here you see, here is level capacity and here is chase demand. So let me illustrate what the level capacity chase demand strategies mean with an example. Let's take some forecasted quarterly demand and 12,000, 28,000, 24,000, 20,000. This is the demand of our computers that we're producing off the production line this year, or this quarter, or this year, every quarter this year. And this is what we're producing of our washing machines or automobiles. This is what we're producing. So I take that demand and put it over here. Here's my 4 quarters. Here's my demand for all 4 quarters. My annual demand then is 84,000. Now, an example or a description of a level capacity production plan, and PP is production plan. And by the way, down here, I have all these definitions for you, and equations and relationships and calculations. An example or description of level capacity production plan is simply to take the annual demand and divide it by the four quarters. And so we'll have 21,000 every quarter. Well, 21,000 every quarter will sum to an annual production of 84,000, which equals the annual demand. So that's a description of a level capacity production plan, but it's not the definition. The definition of level capacity is in the capacity. Well, there's all different kinds of capacities. There's facilities, there's equipment, there's outsourcing, but the capacity we'll be looking at is labor. So labor can create products, can have productivity. And so the capacity is what we're looking at. Well, to connect the capacity of labor with the productivity of production, we have something called a production standard. And so the left-hand side is the labor, the right-hand side is the production. Now, it's 1 FTE is 200 items per quarter, a productivity of 200 items production per quarter. Now, the FTE is an acronym which stands for a full-time equivalent. Now, let me write that down here. Full-time equivalent. And the full-time equivalent, what they're talking about, is a full-time equivalent worker. And this is a very common measure, an FTE. So a full-time equivalent worker is one worker working full-time, whatever their requirements are, can generate, on the average, of 200 items per quarter. Actually, not the average, it's on the standard. The standard output will be 200 items per quarter. So that's something you can use to plan. Now, the reason I say full-time equivalent, not worker, and some people are not familiar with this, is that you can have two actual physical people working half-time. That's equivalent to 1 FTE. 4 people working quarter-time, 25% of the time, is equivalent to 1 FTE. And so in aggregate planning, top-down planning, they're saying how many FTEs do we need? Once we decide we need this many FTEs, then the human resource management says how many people do we need? How many people full-time, part-time, 80%, 20%, 50%, and that has to add up to this many full-time equivalent productivity as far as the capacity is concerned. And so that's why they do that. And FTEs are very common. As a matter of fact, you're a student and you are one student FTE. I'm one faculty FTE. So FTE is a very common measure that people use to manage and schedule and to create plans. Okay, so if 1 FTE is equivalent to 200 items of productivity every quarter, then how many FTEs do we need every quarter? Well, right here, for example, what if I only had a demand of 200? How many FTEs do I need? I just need 1 FTE. But what if I had a production plan of 400 and meet a demand of 400, the production of 400 to meet that demand? If that's all I had, I'd only need 2 FTEs. So what if I had 21,000? Well, I take 21,000, divide by 200, and that turns out to be 105 FTEs in that quarter. And down here, I have the actual equation. The FTE equals production plan divided by the production standard. Okay, and I'll put that up here. The FTE equals a production plan, PP, divided by the production standard of 200. Okay. Now, remember I said there are 4 things. There's demand, there's productivity, there's labor, and the last is inventory. So here's my inventory over here. BI is beginning inventory. EI is ending inventory. Again, down here, I have the definitions, beginning and ending inventory. So the idea is that we have a requirement of the beginning and ending annual inventory is 3,000. We want to start the year with 3,000, and we want to end the year with 3,000. But throughout the year, we're going to be producing 21,000, but our demand varies throughout the year. So what is going to be our inventory? Well, here we have our beginning inventory, and this is a make to stock operation. Remember in the first lecture, this is make to stock. we have a beginning inventory of 3,000. Our production of 21,000 is going into that inventory. So 3,000 plus 21,000 is 24,000. Our demand is coming out of that inventory to satisfy demand. So minus 12,000 leaves an ending inventory of 12,000. Again, the equation is down here. The beginning inventory plus production going in minus demand coming out is your ending inventory. Let me copy that and put that up here. And so there's your inventory equation. So notice we have a labor equation and we have an inventory equation. So right up front, I'll just mention this, not go into much depth in this, but we will have equations to determine the appropriate labor. And these are called equilibrium equations, and having the appropriate labor, the FTEs, is referred to the analysis of conservation of labor. Likewise, these are an equilibrium equation for inventory, and analyzing the appropriate inventory based on whatever our demand is, our productivity, our capacity, our labor, our FTEs, that's referred to as conservation of inventory. So I won't get into that, but in more detailed analysis, we go into all different kinds of analyses with conservation of labor and conservation of inventory. So that's where this goes. But let's back up and let's look at chase demand. Chase demand now. Well, a description of chase demand is I can let my production equal my demand, and that's just a description. Well, my annual demand is equal to my annual production again, but this time my production plan chased the demand. As a matter of fact, it's the same as it. It's matched. Some people call it matching. I don't like that word. I like chasing because it doesn't have to exactly equal it. It just has to chase it. It has to be close to it. And we'll see that later. There's an example of that later. Okay, well, if this is my production, this is just a description of a chase demand production plan. What's the definition of a chase demand strategy? Well, you divide your production plan by your production standard of 200, and I come up with my FTEs, and there's my FTEs. So 12,000 divided by 200 is 60, 28,000 divided by 200 is 140. So there's my FTEs. So there's my chase demand strategy. It's defined by my FTE load. And then my inventory, since we bring down the equilibrium equation for inventory here, and notice demand here and the production plan are equal, so these cancel out, and my beginning inventory just are the same in this example. Now, so those are the level capacity, chase demand, are the different strategies. But there's also a characteristic, a very important characteristic and principle and takeaway from this graph, and something that is one of the most important takeaways from aggregate planning. And we'll use this over and over again in aggregate planning strategies and actually building aggregate plans and production plans. Notice, and here it comes, notice the demand has variability. We talked about variability. It goes up, it comes down, it has variability. The variability is not reflected in the labor capacity, but the variability is totally reflected in the inventory. So for level capacity, the demand variability is totally contained in the inventory levels, and the capacity labor is independent of demand variability, where inventory is totally dependent on demand variability, or the demand variability is totally contained in the inventory. Conversely, with chase demand, notice the demand variability is not in the inventory at all. So therefore, the inventory is independent of demand variability, whereas the capacity labor is dependent on the demand variability. And in this case, all the demand variability is explained in the capacity labor FTEs. So that concept is extremely important. So, and we'll see that a little bit later, that if you want to control your inventory, controlling it says, I want to disengage or decouple my inventory from my demand. You move to chase demand. And then I can make that inventory whatever I want. And we'll see that in just a second in the next page. But if I want to control my inventory, stabilize my labor, then I go to level capacity. Okay, so now we've seen strategies, we've seen some relationships, we've seen equilibrium equations and conservation analyses. What's next? Objective. Let's look at the objective. Let me introduce an inventory objective. Okay, let's go back to the forecasted quarterly demand like we had before. That's the same. A production standard is the same, 200 items per quarter. But instead of a beginning and ending annual inventory of 3,000, then I'm going to eliminate that. And I want an inventory objective. Well, the beginning annual inventory is 3,000, but I want to include an inventory objective of increasing or decreasing the ending annual inventory by a certain amount. And so let's start with level capacity in the first example. So my inventory objective is I want to start with 3,000. I want to end with 3,800. So this is what I had on the first page. So I copied this over so we could see this. Okay. Now here we're saying our beginning annual inventory is 3,000, but my objective is to increase the ending inventory by 800. Hence, it'll be 3,800. And I copied my production standard of 200 because we're going to be using that. Okay, well, there's different ways of doing this. And it's important to see different ways of accomplishing this because depending on the application, one way may be more appropriate or more direct than another way. So know multiple ways to solve a problem. One way is to take the extra 800, put it in the total annual production, 84,800, and divide that by 4. So I have 21,200. So I start with the total annual production. I divide that by 4 to get my quarterly production, divide those by my production standard to get my FTE labor, my capacity. And then my inventory over here with the new production plan, notice it starts every quarter. I'm going to increase my inventory from before over here by 200. So instead of 12,000, it's 12,200. Instead of 5,000, as it was before, now it's 5,400. 200 twice. 2,000, 2,600, and finally 3,000, 3,900, and there's our objective. So that's one way to do it. The other is take the 800, and since we have quarters, divide it by 4 and add 200 every quarter. So I can do it within the actual quarters. So the annual demand will be 800 more. Divide this by my production standard, and I have my FTEs. That's a second way to do it. A third way to do it is take that 800, the extra 800 we're going to add, divide by the production standard of 200 items per quarter, and that would give me 4 quarterly FTEs. Now, why are they quarterly? Because 800 is just items, 800 items. But if my FTE has a standard of 200 items per quarter, and if I divide 800 by 200 I get 4, that means I have 4 quarterly FTEs. That means I have an FTE working full-time every quarter. So I need 4 quarters of an FTE to satisfy the 800. So I can take those 4 and spread them evenly throughout the year. Well, it was 105. Spreading 4 evenly is just adding 1 to each one, so the 105 becomes 106. So And then the 106 times 200 gives my production. You add all four to get the annual production, and then you have your inventory. Now, before I go on, you might be thinking, and a lot of times people say, well, why do you spread the 800 evenly? Why do you spread the FTE of 4 evenly? Why don't you just put it all in the first quarter? Good question. You could. But the whole point here is that we want this is a level capacity. So for a level capacity, if we want a level capacity, then we want the capacity to be constant, to be level. We don't want it to change. So that level capacity is a requirement. Now, if we took the 4 FTEs and put them all in the first quarter, or the 800 and put it all in the first quarter, my FTEs no longer would be level. My capacity would no longer be level. It would no longer be a level capacity. So if I want a level capacity, I have to spread them evenly throughout the year. If I don't, then I'm modifying that to a different strategy. Okay, why would anyone want to do this? Why is this important? Well, the most direct application and the most obvious is that you anticipate growth. At the beginning of the year, you know during this, at the end of the year, in the beginning of next year, we're going to have an explosion of demand, and we have to gear up our inventory to meet that demand. Well, it happens all the time. You're going to have a seasonality. You're going to have the Olympics coming to town. We're going to have a much greater demand, and if you don't prepare for it, what happens is you run out of inventory. You can't satisfy that demand, and it hits the news. They were not prepared, and if you're not prepared, that's mismanagement. And how many times do we see mismanagement and people run out and you don't have inventory to satisfy that? You anticipate your demand. How do you know that demand? You look at your forecasting, and that's why forecasting is important. So, but notice in your level capacity, you're not changing your aggregate planning strategy. You're changing how that strategy is deployed. You're deploying it in such a way that you add an inventory objective to this to address the extra demand that's going to happen in the next year, for example. So that's important. Some people change how they do things, or they change their strategy. We have to operate differently. Well, sometimes if you know what you're doing, and good management is not really changing the strategy so much, is changing how you employ that, how you deploy that strategy to satisfy objectives. So I said increase. I could have said decrease too. But let's go to chase demand. Now in chase demand here my inventory objective is start with 3,000, end with 2,200. So my chase demand is decreasing my ending inventory by 800. Again, this could have been increase or decrease, but I'm just using this as an example. This is a good example. So if I decrease it by 800, it's going to go from 3,000 down to 2,200, 800 less. Again, how do I do that? Well, again, I have 800. I want my annual demand to be 800 less, but this is chase demand. So probably the more direct way is take this 800, divide it by 4, and subtract 200 from my production plan every quarter. So instead of 12,000, it's 11,800. Instead of 28,000, it's 27,800. So I subtract 200 every quarter, such that every quarter I have, instead of 3,000, I have 200 less, 2,800. Instead of 3,000, I have 400 less, 2,600. Then 600, then 800. That's probably the most direct way. Another way, which is even better sometimes, is take the FTE, the 4 quarterly FTEs, and spread and subtract that evenly throughout the year, subtracting 1 FTE every quarter. So subtracting 1 FTE, instead of 60 is 59, 140 is 39, 139, 120 is 119. So I subtract 1 every quarter, then multiply this by my production center to get my production, they got my annual production, and then I have my inventory. So whether you go through your production plan or your capacity, either way is fine. A lot of people, if they start with, most companies will start with the FTE. Here's our capacity. They'll know what their demand is going to be. They'll know what their production is. And they say, here's how we're going to plan. So the planning, the aggregate planning part, here's the FTEs, and that goes to HR. In other words, you're not going to say to HR, we need to produce this much. Okay, well, they have to go through the FTEs. Aggregate planning will report the FTEs. Now, why would anyone want to do this? Well, this is an even more important question. Remember, we had the demand in the variability in the demand is independent of the inventory. But this inventory is not constant. But it is it decreases from 3,000 to 2,200 in a straight line in a constant rate. So even though it's not constant, the rate is constant. The decrease in the rate is constant. And this variability, again, is reflected in the capacity. So why would anyone want to decrease their inventory? Well, a very good question, very good answer to that. It's a good question. A good answer to that is saying, well, all these, our people, our workers, our production process is so efficient, so good, that every time we have a production plan, our people meet that production plan so well, and we meet the demand, and all this inventory over here we really don't need. And we're paying for all this inventory that we don't even use, because we are so efficient that we produce things according to our demand so well that we can almost do that as the demand comes in, and we're actually moving from a make-to-stock operation to a make-to-order operation because we're so efficient. So you need less and less of the inventory. Well, if I can reduce this by 800, and the closer my capacity can meet my demand, the less I need my inventory. And so if I can reduce it by 800, I can reduce it by 1,600 or 2,000 or 3 or 2,500. So theoretically, if I move to a make-to-order operation, I can reduce my inventory to 0, and then it would be a pure make-to-order operation. But usually in production, if you're producing products, you don't necessarily have 0 inventory. But how much inventory should you have? And if you have too much, it's too costly, and you're wasting money. If it's too little, it's too risky, and you can run out of inventory and lose sales. So how much inventory should you carry? Well, the amount of inventory you should carry here, it depends on how much variability or uncertainty you have in the demand. Now, this demand displays variability. It goes up and down. But how accurate is that forecast? How much uncertainty or variability is there in that 12,000? What about the 28,000? What about the 24,000? How accurate is it? Well, if you say, well, it's not exactly 24,000 every third quarter. Sometimes it's 24,100. Sometimes it's 23,950. So there's a little bit of variability. Well, how much variability is there in the actual forecast? Now, the demand does have variability, but how much variability is there in the uncertainty of every forecast? And once you have identified that variability, that defines how much inventory you should carry, because you're guarding against running out of inventory. So if you have demand, but you do not have inventory that meets that demand, that's called stock out. And so down here, the stock out level, and we'll see this in inventory. Okay, let me do it this way. Okay, the stock out level here is dependent on the probability of running out of stock. And how do you do that? Well, you carry more inventory. You're carrying this inventory over here to guard against your stock out. And the stock out level is the probability of having stock out, and you want a very low probability. And how do you do that? By carrying more inventory over here, especially when you move to a make-to-order operation. And so in production, it's not a pure make-to-order. But why would you want to move to a make-to-order? Well, one thing, you're more efficient. Two, you can lower your inventory, and so you can satisfy your demand and lower your cost. So you can meet your demand and do it with a lower cost, and so you have a win-win situation. Okay. So there's some concepts with this objective. Okay, let's see here. Okay, one more thing I want to mention before I leave this page. A very important point. Let's look at this right here for a second. Let me give you a scenario. Suppose you get a call and you say, "Hey, can you help me come over here? I have trouble with my inventory. I have trouble with my inventory. I need some consulting work. Can you come and help me with my inventory?" And you go, "Okay, what's wrong?" So, well, we run out, then we try to build up, then we run out, and we just can't control our inventory. Could you please come and help us? You go, "Okay, fine, I'll come." So you come and you say, "Tell me about your operations." And you sit down with the manager and they say, "Okay, well, first of all, our operations are great. Our people here, our FTEs, are the best in the industry. When we give them a quota, when we give them a production plan, they meet that production plan so well. It's so good. It's the best in the industry. There's no problem here." That's not where our problem is. And we didn't have you come here to talk about our FTEs. Our problem over here is inventory. What's wrong with our inventory? And you say, "Well, let me ask a few more questions to understand your operation so I can answer your question." Okay. So you tell me your FTEs are very good at producing whatever the demand that they have. That's right. So how do you forecast your demand? And they say, "What do you mean?" "Well, how do you forecast?" Says, "What do you mean forecast? We don't do forecasting." "Well, how do you know what your demand is?" "Oh, that. Oh, well, that's easy. Whatever our demand is in that quarter, that becomes our production plan the next quarter." Oh, so basically you have a moving average with a window of 1. It's called the naive forecast. A lot of companies do this. So this 12,000 then is your demand in the second quarter. Yeah. And so if you produce 12,000 and your demand is 28,000, then you're going to run out of inventory every second quarter. "Yeah, we do. I told you we run out of inventory. We have an inventory problem. Help us with our inventory." "How did you know we ran out every quarter? I didn't tell you that." I says, "But something else. If your demand is 28,000, then 28,000 is going to be your production in the third quarter. And if your demand is 24,000, you're producing 28, then you're going to start building up your inventory." "Yeah. In the last half of the year, we build up our inventory. Then we run out in the second quarter." "How did you know that it was those quarters? How did you know that?" And then you say, "Well, what you can do, since your FTE, since your production people are so good, what you can do is just have some forecasting. Have a forecasting department, hire some forecasting people, and then lower your inventory, and then meet that demand, your forecasted demand, and you're going to not go out of inventory because you lower your inventory, and then you meet your forecasted demand and not go out. And you won't run out of inventory." You see, that does not make sense to me. In our industry, if we run out of inventory, we make more inventory. And so you're telling me that I can lower my inventory and not run out? Yes, if you have good forecasting. If you know what to forecast and know what the error is, and you know what your forecasts are, and your FTEs can meet that demand, you don't need this inventory. It's connecting the sales with your operations, with your inventory, with your labor. And it's connecting everything together. And now a lot of them who are doing operations and doing this planning go, I never thought of that. I never knew that. This is not hard. Where can I find people who know how to do forecasting? And if I was sitting there next to you, I say, hire this person. They know it quite well. They can do this extremely well, no problem. Okay, so here's a scenario that's not uncommon. And so this is it's so practical. It's easy once you know it, but it's not obvious because a lot of people don't do it. But once you see it, it's not hard. Okay, let's go on. There we go. Okay, let's go on to, let's do a cost analysis. Cost analysis of labor and inventory. Okay, let's start with some definitions. Define the unit cost and the total cost for inventory hiring and firing. Again, we're looking at labor and inventory. So the C sub C is a unit carrying cost, which is $9 per item per year. C sub H is a unit hiring cost, which is $150 per FTE. Now, I'm using the word hiring as a descriptive term, not literal. Hiring means adding FTEs. You're increasing FTEs in your production. And hiring could be going from part-time to three-quarter time, and so it's increasing the number of FTEs. It doesn't necessarily mean hiring people. Hiring just means increasing FTEs. I don't want to say increasing because hiring and firing are descriptive terms. And firing, C sub F of firing, is $250 per FTE. Okay. Now, if I take the unit carrying cost, which is $9 per item per year, and notice it's prorated over the number of items and the time. So if it's $9 per one item per 1 year, it'll be $18 for 2 items over a year. Okay, if you had 2 items. If you had a half a year of 1 item, it'd be $450. So you can prorate it. Now, if I took the average annual inventory over a year times $9, then that's going to be my total carrying cost. If I take the number of annual hires and fires times the unit cost, those are my total hiring cost, total firing cost. These are the 3 total costs that we will be looking at. And we will be minimizing or analyzing the cost between the strategies. So if I add all 3 of those together, I'll just say total cost. So here's my definitions up here. So let's apply that to level capacity. I take these down here and I kind of copy them here. Unit labor, inventory, hiring and firing, production standard. Okay. So this table right here came from the very first page. As a matter of fact, let me go back and show you. Page 2, page 1. This is the very first page. I take this table right here and I copy it down here. There's page 2, page 3. I copy it right here. Okay, it's the same table. But I call this a solution table. Because I call it a solution table because this is the actual solution, the minimum amount of information to define level capacity. It has your demand, your productivity, your labor capacity, and your inventory. So those 4 things is in this table. That's the minimum amount of things that will define a solution in this development. I also had my annual production demand and my average inventory. Now, I'm going to analyze this with a cost analysis. I say analysis, I could have said, and I probably should have said, cost analysis. But this is an analysis table. An analysis table could be cost analysis, it could be risk analysis, it could be labor analysis, it could be all different kinds of analyses. I pick cost. Okay, first of all, I'm going to bring down my FTEs. Bring these down, and there they are. Now notice I'm hiring and firing no one all year long because it's the same level of FTEs. Well, that's easy. The total hiring and fire is 0. And so my total hiring and firing cost for the year is 0. That's easy. If I bring down my inventory, which I do right here, notice I do have inventory. So there will be inventory cost. So I take the annual average, and taking the average, you average all 8 numbers to be safe. From the beginning to the end, on the average, all 8 of those numbers is 5,500 items. Each one of those items required $9 to carry throughout the year. Therefore, my average inventory times 9 gives me my total annual carrying cost of $49,500. Okay, so then I add these 3 costs together, and I have my total cost, just like I did up here. Okay, and there it is. Now, before I go on, notice over here I have 3 more columns with more data. It tells us a lot of information. Since I'm analyzing the cost, this is the analysis of the cost for the year, but over here, this is the total carrying cost per quarter. So all I'm doing is taking the average inventory for each quarter. 3,000 plus 12,000 divided by 2 is 7,500. So I take the average inventory for each quarter, each quarter, each quarter, each quarter. Whoops. Okay, there's my average inventory. Now I know my carrying cost is $9 per item per year. But then what's my carrying cost then for every quarter? I divide 9 by 4. 9 divided by 4 is 225. 2, 4, 6, 8, and 25 is 9. So 7,500 carry through a quarter with a carrying cost of $225 a quarter gives me a total carrying cost per quarter of $16,875. So this is my quarterly total carrying cost. If you add this up, the $49,500 will be the same as this because you do the same arithmetic just in different orders. So why do I go to all this work? I could have gotten that $49,500 with just multiplying those 2 numbers, because this gives you some good information, some very good information. For example, a good example is budgeting and planning. Okay, this is your carrying cost. This is how much your warehouse is going to cost to carry this inventory item. Okay, well, how much money do you need? Well, for the year, I need $49,500. I can round that up to $50,000. I need $50,000 just to manage my inventory, just to carry it. Okay, fine. Then if you're going to budget that, how would you budget it? Would you budget it? See, $50,000 divided by 4 is $12,500. Would you budget $12,500 every quarter? Well, if you did, then the first quarter you're going to spend more than your budget. In the second quarter, you're spending more than your budget. And you go, oh no. So you go to a budget meeting at the beginning of the year, and they say, we've given your annual budget is $50,000. So we're going to budget you a quarterly budget of $12,500 every quarter. And so you raise your hand and say, wait a minute, I'm going to need more than that in the first half of the year. I'm going to need like $17,000 in the first quarter, and then maybe $19,000 in the second quarter. I go, why would you need that? We have a level capacity, so you have a level. We have a level capacity here, so we're going to have a level budget. And you say, no, it doesn't work that way. Level capacity, the variability in the demand will be reflected in the inventory, and the inventory then, that variability will be reflected in the inventory carrying cost. And they go, well, that's your problem. We give you a level budget. And you go, well, okay, it's not okay, but I can't do anything about it. So halfway through the year, they budget you $25,000, but you've spent $10,000, $20,000, $35,000, $36,000. And so they say, well, obviously, the material management, the operations people, the inventory people, the material management manager, they're overspending. And linearly, doing a regression here is 16, 19, it's just going to keep going up. So 30, 16, 20, we're going to budget you $20,000 for the last half of the year. He says, no, I need less than that. And they go, you have demonstrated, and I'll use regression and demonstrated that your budget's going to go up. He says, no, it's going to come back down. And so they budget you 20,000 and you come in less. And so what's going to happen the first quarter of the next year? They're going to cut your budget again. And so if you're reactive, if you have a reactive budget, which a lot of companies do, then see how this vicious cycle can just grow and resound out of control. So instead of being reactive, be proactive. And again, this is easy, but it's not obvious. A lot of companies don't do it. So you need forecasting, you need a strategy, and then understanding how to budget for your inventory. Okay, let's go on to chase demand. So again, I copied all the values down here. And again, I copy my solution table from the first page again. So now when I bring my FTEs down here, right here, now my FTEs here are not the same. They're increasing and decreasing. And so hiring is increasing FTEs, firing is decreasing FTEs. So here's the logic. During the first quarter, I have 60 FTEs. Beginning of the second quarter, I need 140. So beginning of the second quarter, I have to increase this 60 to 140. That means I hire 80 at the beginning of the second quarter. So during this quarter, I have 140. At the end of that quarter, I have 140. At the beginning of the third quarter, I have 120. So at the beginning of the third quarter, I need to decrease 140 down to 120. So that decrease is firing 20 or decreasing 20 at the beginning of the third quarter. I do the same thing for the fourth quarter. And at the end of the fourth quarter, I have 100 FTEs. But at the end of the fourth quarter, I have 100 FTEs. But then the next quarter that's going to occur is going to be the first quarter, which is 60. So I have to reduce 100 down to 60 the first quarter of the next year, because this just keeps going. Our company doesn't operate just 1 year at a time. It operates year after year after year, and you have to plan accordingly. So the beginning of the first quarter of every year, since the last quarter of every year you have 100 FTEs, if the first quarter of every year you only need 60, you have to reduce that 100 down to 60 or fire or reduce 40 at the beginning of the first quarter of every year. So here I have my hire and fire. I add that, and notice since my beginning and annual inventory is going to be the same, then my what you hire and fire should also be the same. And so you multiply by the hiring and firing unit cost, and there's your total hiring and firing for the year. Now when I bring down my inventory, well, this is easy. It's 3,000. It's all the same. Okay. Well, the average of all the 3,000 is just 3,000. Times 9 is 27,000. Add these up, and there's my total cost. And also, this over here is going to be a lot easier, isn't it? Well, 3,000, 3,000, 3,000. 3,000 times 225 is 6,750. So all these are the same. Again, the 27,000 should be the same. But notice, now my budget is constant. Well, we mentioned that last time. So when you have a pure chase demand strategy, that would result in a level total carrying cost. When you have a pure chase demand capacity, you'll have a level or stationary inventory, which will result in a level or stationary total carrying cost. And that will drive your budget. So the example here is quite often like up here when we said, oh, okay, well, we're going to give you a constant budget, a level budget, okay? Well, making that decision down here in your inventory, that decision down here assumes that you had a chase demand strategy up at the beginning. And if you don't do that, if you don't have that down here, that's referred to as a disjoint. And so when you make decisions that are local, instead of looking at the global impact or the configuration of your whole strategy, you'll have disjoints, and those disjoints, discrepancies, will just increase inefficiency, increase cost, and increase mismanagement. So this stuff is looking at the cost or metrics of what you're doing. You have strategies, you have characteristics, and you have the metrics and the cost analysis. So these are very important in analyzing things. Now, before we go on, let me ask you a question. What if the carrying cost of $9 per item per year, suppose that begin to increase $9 to $19 a year, to $900 a year, to $9,000 per item per year. When your inventory becomes extremely expensive to carry, then which one of these strategies would that drive you toward, level capacity or chase demand? Well, there's a couple of answers there. First of all, my average inventory for level capacity up here is 5,500. My average inventory for chase demand is only 3,000. So if my carrying cost increases, the increase would be lower for the chase demand. That's one answer. That's true. But a better answer is, as that carrying cost, as this 9 here begins to increase, and you move to chase demand, as you move to chase demand, the better your FTEs can satisfy your demand, the less you need this inventory. And so if this unit cost increases, then with chase demand or a make to order operation, you can start decreasing it. As that unit cost increases, you can decrease your inventory. And as that unit cost keeps increasing, keep decreasing your inventory as long as you don't have stock out. And if that's true, if you do that, then what happens is that you have no change in your cost. This cost remains the same. It doesn't change. Interesting. This doesn't change. All you do is you have your inventory objectives to stabilize your costs over here such that this doesn't change. Because if this goes up, this goes down to maintain a stable cost. Interesting. So in aggregate planning, you can absorb changes in, say, the economics or the cost structure or some types of catastrophes. You can absorb certain costs to a point. Well, there's going to be a point where you can't do that anymore, and then you have to do something different. But small changes with good management, you can absorb those costs and have no effect on your bottom line. Okay. Now notice I said mixed trade. Notice I said move from one to the other or between level and chase. These are called pure strategies. Level and chase is a pure strategy. Something between level and chase is referred to as a mixed strategy. Now our textbook calls this a hybrid strategy. Let me just say hybrid. Some textbooks call it a hybrid. Okay, I like a mixed strategy because it's mixing things together. Now, assume an arbitrary mixed production plan. Now, here's my mixed production plan right here. I'm just starting with a production plan. But I arbitrarily selected this plan. I did not calculate it. I want to make that point. I didn't calculate it. I arbitrarily selected it. But I selected it under to satisfy 3 conditions. Well, the first one is easy. I want it to be mixed, so it cannot be level or chase. If it's level, it's level, it's chase, it's chase. It can't be level or chase. It has to be something other than that. So it can be a lot of other things. That's the first condition. The second condition is I wanted the total production to equal total demand. I wanted those 2 numbers to be the same. Let's make this bigger for now. I wanted these two numbers to be the same. That's the second condition. Now the third condition is, and this is important for this development, is I'm going to pick this production plan such that my inventory does not go negative. No negative inventory in aggregate planning. And notice it can go to 0. 0 does not mean stock out. Actually, stock out means negative inventory. Negative inventory refers to stock out. In other words, you have demand, but you don't have inventory to meet that demand. That's referred to as stock out, and that would be illustrated here with negative inventory. So no negative inventory in this development. Now, when we get into inventory control, in inventory control, we do look at inventory. There we have back orders and buyouts and do all different types of ways of doing it. A lot of textbooks, and our textbook will do this, they'll say, oh, you can have negative inventory. That's called back orders. And I don't like that, because back orders is only one way to do that. There are different ways of handling stock out situations or mitigating the probability of having stock out. There's different ways of doing it. Back order is only one way of doing it. So, and that's another lecture. That's another discussion. But to focus just on aggregate planning, let's allow no negative inventory. Okay. Having said that, then I'm going to take this down here to the analysis table. There we go. To the analysis table down here. And so here's my FTEs, and I'm not going to go through this again. I've done it. I'll let you do that. Here's my inventory. I bring this down here. I'll let you do that. And here's my cost. So I'll leave this kind of like as an exercise to make sure that you understand. Just go through this mentally and say, I see how this is done. Okay. But now that I have a mixed strategy, arbitrary mixed strategy, level and chase, now I can start doing something called comparing and planning. This is aggregate planning. So a comparison table down here, let me make this larger. A comparison table, I'll bring the level down, I'll bring the chase, I'll bring the mix, and I'll compare them. So this comparison table is really where aggregate planning occurs. You say, do I want a pure level? Do I want a pure chase? Do I want a mix? What do I want? Well, the aggregate planning results in a production plan, which results in a decision. Well, to make a decision, you need alternatives. To have alternatives, you got your comparison table. So here's where aggregate planning actually happens. So at this point, notice this table does not have everything. This table only has a production plan, FTE, and total cost. That's all we're looking at. All right? Inventory is not in here. There's a lot of things that are not in here. So this comparison table in this discussion with the planning committee is looking at total cost and FTEs in production. That's all it's looking at. Well, for example, let's go a little deeper and let me just show an example of this, of how this discussion would go, and also to motivate aggregate planning. Look at these costs here. And as a matter of fact, let me go down one. Let's round this off to round this up to 50K, 50,000. Round this up to 60 just to have some round numbers and for planning purposes. And round this up to 40K. That's good. Okay. So let's just look at these numbers. So when you look at these numbers, you say, okay, let's see here. I have the same FTEs. I got my beginning and ending inventories. Everything is the same. I'm just looking at different, just how do I use my labor? How do I plan throughout the year? Well, level is 50,000. Chase is 60,000. Mixed is 40,000. Well, which one is the lowest total cost? Well, it's going to be mixed. That's 40,000. Okay. So what criteria am I focusing in on here? So let's have another layer down here. Or right here, what does level actually focus and control? Labor. So level has a maximum control over labor. You have a fixed labor market. your labor force is fixed. It doesn't change. What is chase? Inventory. Inventory is the focus. Inventory, I can increase it and decrease it. I have control. Most control over inventories with chase demand. Well, what characteristics do I have on the mix in this example? In this example, it's cost. So which of these are going to be important to our company? The inventory, the labor, the cost? Well, at this point, hopefully, you can probably see some kind of a triangle in here. And just to emphasize this, I can have a triangle with level, chase, and mixed and say, okay, do we want pure level, pure chase? Do we want this mixed or something in between in here? And so now you're looking at how people plan aggregate planning and production. This can also be in services. This can also be in nonprofits. It says where in here, how do we want to use our labor and inventory, and how important is the cost? So some of you say, well, cost is most important. Not necessarily. Sometimes in startups, you have a lot of money. The cost is there. I mean, the money's there. Sometimes you have nonprofits, or sometimes you have government. Sometimes you have military. The cost is not that important. Your objectives are important. Using your labor efficiently, you're not going to fire people when you have high-skilled labor. Okay, your inventory may be really important because it's so expensive. I don't want to increase and decrease my inventory because it takes a long time to build the big machinery. Okay, so every company is different. Let me put it that way. And so one is you can look where in here do we want to be in our company. But if you're in a competition, competitive market, where do our competitors lie in this triangle? Where are they? What do they do? Well, if this is where they are, if all of our competitors are up here on chase, maybe we can come down on the cost and have a cost marketing plan and say everyone will come to us because they're going to save money. Okay, and so these are only three. You can have 4, 5, 6 and come up with a radar chart with all these different objectives in here. And the larger the competitive market is, you'll have people all over the place. And that's exactly what's happening today with a lot of high tech. Okay, let's go on. Aha. Let me point out to you that this, oh yeah. Wait a minute, let's look at this. Look at these numbers, 40, 50, 60. So if you have chase demand, it's costing you $60,000. So instead of having this production plan and these FTEs, what if you change these FTEs in this production plan? What's the difference? The difference is you're saving the company $20,000, which is 1/3 of the cost of your warehouse. You can lower the cost of your warehouse by 1/3. That is significant. People will spend millions of dollars to lower their costs by 2 to 5%. And you're talking about over 33%. So aggregate planning can have an enormous impact on your operations if done properly, and if you have people know what you're doing. That's why you need operations people doing operations, not people with other disciplines doing operations, because they won't understand this that well. They likely will not. Some do, most don't. So, well, I got this 40,000 by arbitrarily selecting that production plan. What if I could solve for a production plan that minimized that cost? And you can, and you do that with something called linear programming. Linear programming is an optimization technique which determines the minimum cost production plan. Okay? So in the homework in this course, we'll do this on one problem. just to show you at the undergrad level that it exists. Go through it one time. You've done it once because you know it exists. Doing it once probably isn't enough to do it over and over again unless you decide to learn it. If you go into it and learn it, you'll learn a lot about it. Okay, so here's the idea. I'm going to use Excel to solve this thing, and in the lecture, I'm going to go over this and just show you what the lecture says here, and this is the answer down here. Notice the answer is 37,750, and that's pretty close to what was up 39.5. It's pretty close to 39.5. Okay, so we selected well. But anyway, that's the minimum down there. I'll show you how to set this up, just describe it. I'm not going to go into it. But when I cover the homework, I will go through and actually work this in Excel. Because here I have this in the lecture using Excel, but I'll actually demonstrate this with the homework problem on the homework video. Okay. So the idea here is that first of all we have our demand. Now in this case, we're going to notice down here I have my target cell, this right here. I want that to be minimized. I want to minimize my total cost. And then by changing the production, hire, and fire, so these cells here, these are going to change. And so let me do this, home. Let me shade this in slightly. Whoops, wrong shade. Let me get to the shade. There's. Oh well, I'm not going to do it. Oh. I need to shade with the tape. Shade the table. Shade over here. There we go. Okay, that's too much. Oh, I'm spending too much time on this. There we go. Okay. I'm going to ask Excel to change all of these numbers here and change those numbers such that this over here is going to be minimized. So I'm going to change my production, hire, and fire, change all those things around such that over here, that number right there is going to be minimized. So that's pretty much what I want to do. Okay, so that's what I'm after. So here I'm changing all of these cells, and it's going to do that automatically for me. Interesting. So it changes these to minimize this. But in order to do that, I have to connect these variables up here with the actual total cost. I have to connect them, and that's what the equilibrium equations of labor and equilibrium equations of inventory is for. It's exactly what this does. There we go. It's going to equate all these things. So essentially, I'll take, here's my labor equations down here. There's my FTEs, and I'm going to these need to be higher. There we go. These go here. There we go. That's the way it should be. There we go. Somehow they got messed up. So I'm going to have my FTEs. So these FTEs will be calculated from my production plan. See, production divided by production standard of 200. The left-hand side here, this is going to be these equations. Now these equations will take the hire and the fire and the FTEs and combine all of these and connect all of these together. My equilibrium equation. This is my equilibrium equation. And this is my equilibrium equation for my inventory. And once I get all that together, I calculate my total cost and minimize it. And as I say, I will be looking at this and show exactly how to do this in the homework video. Okay. So now, my solution, analysis, and comparisons tables. So here's my minimum cost plan. I take this, create my solution table. I bring it down here and create my cost analysis table. Okay, and now I can compare my level, chase, mixed, and my optimal, my minimum cost mixed, and there they are. And that's just for this cost comparison analysis. Then I can have other types of analyses. Okay, now continuing on, relationships are going to be important. Now, this relationships and definitions is just a brief introduction to something called capacity and productivity. So these two time standards here, these two right here, let me bring this down here. The time standard, these are constants. 1 year, in this course, everything we do in scheduling and inventory, everything we do 1 year is equivalent to 52 weeks, 12 months, 4 quarters. That's all equal. And 1 week is 40 hours a week. So that's our standard. Well, if that's true, then I can say, well, how many hours are there in a quarter? Well, I take 40 hours a week times 52 weeks divided by 4 quarters, and it turns out to be 520. So that's my FTE time standard. So that's how many hours an FTE will be working based on this time standard definition. So that's a definition, and this is a definition. So both of those are definitions. Now, once you have that, then you start looking at your standards. These are your time standards and your FTE time standard. Well, down here you say, okay, well, my production standard is 1 FTE was 200 items per quarter. That's what we've been using. That can change. And it will change from company to company, from product to product, even from department to department, because different people are efficient. But then you have something called a labor standard. In other words, it says, well, how many hours does it take an FTE to make 1 item? Okay, well, 1 FTE can make 200 items in a quarter, but it takes 2.6 hours to make 1 item. And so those are really 2 different ways of looking at it. One is looking at a quarter, items in a quarter. The other is hours per item. Okay, and the other is items per quarter is the time. The other is items in hours is the time. Okay, well then if you have your time standard at 520 hours in a quarter, 2.6 hours per item will give you 200 items per quarter. And so this right here, your FTE time standard divided by your labor standard equals your production standard. That is a property. That's an equation. That's a standard. I mean, that's going to be an equation that we'll be using quite a bit. The production standard equals the FTE time standard divided by labor standard. And so the idea here is, why do you do that? Good question. Well, this is pretty much fixed. That doesn't change. But the labor standard is looking at individual workers. How efficient is that job? In other words, if they can have training, then those hours per item will decrease. If they can have ergonomics or layout, like in quality control, you're going to lay out your workspace much more efficient. You're going to reduce the amount of waste you have as far as extra effort or work. You don't have to carry it so far. You can just move it here. And so if you can make your workspace more efficient, you can lower those hours. If you lower those hours, you're becoming more efficient. So the labor standard here, let me do it this way, looks at the worker. I'm going to say work space. Your workspace, or I'll say the worker. Okay, but then up here, the production standard looks at the planning. Okay, let me say worker. This is the worker's efficiencies. This is look at the top-down planning. Worker efficiency, and this is more of a top-down planning. And so one's bottom-up, the other's top-down. and so this comes together. And so this is how you would make things more efficient, and here's how you plan to make sure you meet your demand. Okay, and so this is just getting into worker to capacity and productivity. Okay, so down here, the aggregate planning with overtime production, that goes beyond the BANA 3000 course and chase demand with overtime. And I'm going to go into this in this lecture. This would be another lecture. Okay. Well, that's all I have for aggregate planning for this course. And so between now and the next time I see you, I'll be working some of these problems in the homework. And so I'll show you how to apply this. This has been an explanation. The homework is going to be an application. So in the homework, you can see how this is applied, how these concepts are applied within problems. So between now and the next time I see you, I want to urge everyone to be very, very